So third method for the separation of the chiral chromatography is the addition of the chiral mobile phase additives. So we have conversion. First one is the use of chiral adsorbent. Second is the conversion to distereoisomers, and third is the chiral mobile phase additives. This is the easiest method out of the out of these three methods, and it is less expensive as that of the other two methods, because in this case we are using the conventional adsorbents. हमें normal adsorbent जो आप use करते हैं वो use करना है, और normal solvent जो है वो use कर सकते हैं. Only thing is that we need to add the chiral additives in it. Now these chiral additives are generally used to perform direct chiral separation on thin layer chromatography, and the mode of separation in this case is that these chiral mobile phase additives जो हम add करते हैं, they result in the formation of the pair of transit diastereomeric complexes. That is, in a solvent, when you add the chiral mobile phase additives, जब आप chiral mobile phase additives add करते हैं, वो क्या करते हैं, वो एक ट्रांजिट डायस्टीरियो आइसोमेरिक कॉम्प्लेक्स बनाते हैं. दो रेसिमिक मिक्सचर है आपके पास, दो एनेंटियोमेरिक, एक एनेंटियोमेरिक कंपाउंड आपने डाला जिसपे दो आइसोमर्स हैं, वो आपने अपने कॉलम में डाला या अपने टीएलसी प्लेट में डाला. देन यू ऐड अ सॉल्वेंट एंड यू ऐड द chiral मोबाइल फेज एडिटिव्स इन इट. वो chiral मोबाइल फेज एडिटिव्स जो आप ऐड करते हैं, वो क्या करते हैं, वो इन दो एनेंटियोमेरिक कंपाउंड्स के साथ, एनेंटियोमेरिक आइसोमर्स के साथ transit diastereoisomeric complex बनाते हैं. Now these diastereomeric complexes have then the different properties. As a result, they will be separated on the basis of their interaction with that of the solvent and with that of adsorbent. Now there are the ways by which these chiral mobile phase additives work. Either they form the stereoselective complexation with the mobile phase. जो mobile phase है जिसमें आपने chiral phase additives add किए हैं, आपकी जो एनेंटियोमेरिक मिक्सचर है वो उसके साथ जो है स्टीरियो सिलेक्टिव कॉम्प्लेक्स बनाते हैं, जिनकी प्रॉपर्टीज फिर डिफरेंट हो जाती है, उन दो कॉम्प्लेक्स की प्रॉपर्टीज डिफरेंट हो जाती है. दूसरा तरीका ये है, जो आपने कायरल एडिटिव्स ऐड किए हैं, दे गेट एडसॉर्ब्ड ऑन द सरफेस ऑफ एन adsorbent. As a result, now this surface will behave differently for two different isomers. दो आइसोमर है, आपके adsorbent में chiral additive phase add हुआ है, जो adsorb हो गया. Now these two isomers will behave differently. As a result, they will show the differential migration rate, that is their distribution coefficient will be also different. Third is what I was earlier discussing, is that they result in the formation of the labile diastereoisomeric complex or the mobile diastereoisomeric complex. That these are the formation of the transit diastereoisomeric complex. Now these are the three methods by which the chiral mobile phase additives work. That is either forming the stereoselective complexation, either the chiral additives are adsorbed on the surface, or they form the transit diastereomeric complexes which have the different distribution ratio. As a result, these isomers can get separated. So there are advantages that are associated with the chiral mobile phases. First advantage, as I have discussed, is they are less expensive as compared to that of the other two methods, because here we use the normal conventional adsorbents and we use the normal solvents. Only thing is we are adding the chiral mobile phase additives. Second is the concentration of the chiral additives can be easily changed or tuned. We can change the concentration of the chiral additive according to our need, and then we can tune it. That is our concern. We can change the concentration so that we can bring out the efficient separation. Third is there's a large availability of the chiral additives which can be added to the solvent to bring out the separation. Some of the examples are here. That is cyclodextrin, brucine is there, galactouronic acid here, tartric acid is here. So there are the different examples that can, which of the additives which can be added to the solvent to bring out the enantiomeric separation. So there is a list of the examples of some drug molecules in which we are using the chiral mobile phase additive. So this is a drug molecule, and this is the chiral mobile phase additive that is being added to the drug molecule. And then we are using the normal mobile phase, and we are using the normal stationary phase to bring out the separation. Only thing is that we are adding the chiral mobile phase additives in it to bring out the resolution of the racemite mixture of the drug molecules. Now there are advantages and disadvantages that are associated with the chiral mobile phase additives and the chiral stationary phase. These are certain disadvantages with that of the chiral mobile phase. Advantages that I have discussed, that It is less expensive as compared to that of the other two techniques. There is a large availability of the reagents. Uh, Further, you can tune the concentration of the chiral reagent to bring out the efficient separation. But there is also the disadvantage that it requires a larger equilibration time for the separation of the chiral molecules. Second, it is difficult to control the conditions in case of the using the chiral mobile phase additives. So the results are less reproducible and the assays are less robust. While in case of an chiral stationary phase is that there is a less wastage of the chiral selector because you can reuse the chiral stationary column once the separation is over. So they can be used again and again. Separations are more reproducible in case of the chiral stationary phase, but there are again disadvantages that we have the fewer variables to manipulate because you have the chiral stationary phase. It is once synthesized and it will be always like that. So you have no advantage that wherein you can modify the chiral environment. While in case of an additives, you have this advantage that you can use any type of an additive to bring out the efficient separation. So this ends up our the chiral separation. The next topic is about the high performance thin layer chromatography. Though high performance thin layer chromatography is the same as that of the thin layer chromatography, there is no much of difference in terms of its principle, in terms of its separation technique. Only thing in between the HPTLC and the TLC is that in case of a high performance thin layer chromatography, the particle size is around 5 to 10 microns and the adsorbent thickness is 10 to 50, 100 to 150 microns. Because of this, that is the reduced thickness, जो आप thickness decrease कर रहे हैं HPTLC में and size particle size decrease कर रहे हैं, the separation becomes faster and there is a results becomes more accurate and there is less possibility of the